host Ruth Kirubo, and today we want to look at map work and want to look at map reduction and map enlargement. And before we further ado, we know that to enlarge is basically to make something appear bigger in size. For example, if you had this grid here where we have the agricultural sugar station, you can make it to appear maybe twice that size. It can be 4 times that size, depending, 5 times, 6 times, depending on various factors. You can also get to reduce. Maybe you want to save on space, you want to save on cost. Yeah, maybe don't have that. Okay, sorry for that. So you're saying you get to enlarge. So let's look at the notes on the same. So someone can ask what is map reduction and what map enlargement is. So I've written that map reduction involves the decreasing of a scale of a map, essentially making the map smaller compared to the area it represents. What are we saying? That you're getting to reduce the map, especially when you're printing large-scale maps, to fit onto smaller papers, let's say on an atlas, or when creating insets with larger maps to show detailed areas. In short, what you're saying is the representative scale gets to increase. For example, for East Africa, which was 1 centimeter, for the Kisumu East, it was 1 centimeter on the map, represents 50,000 centimeters on the actual ground. So you can get to increase and say maybe 1 centimeter on the map represents perhaps 100,000 centimeters on the actual ground. Here you're saying that the original representative scale has a smaller denominator than the new scale. When we go to map enlargement, we are saying the map, you're generally increasing the scale of a map, making it larger compared to the area it represents. This is usually done to show more details in a particular area. So here you find that there is reduction of the representative scale. For example, if it was 1 centimeter on the map represents 50,000 centimeters on the ground, as seen here, you get to reduce it so that maybe it can be 1 centimeter represents 25,000 centimeters on the actual ground. So in summary, map reduction, you decrease the scale, while in map enlargement you increase the scale. So it's all about adjustment of scales, whereby we know the scale is the ratio of the distance on the map vis-a-vis the distance on the actual ground. So the factors to consider when doing map reduction and map enlargement is: 1, you consider the scale. So we have already said that. So the scale at which the map is being reduced or enlarged is important to consider. Sorry for the background noise, my son is feeling a bit unwell, if you do understand. So I was saying the scale is one factor, and it will determine how much detail is visible. So the bigger the scale, it means the fewer the details that will feature. But if it's smaller, the scale, then you'll get to see more details. Then you're seeing the purpose of the map, or that reduction. Yeah. So the purpose will influence the choices made in terms of what features to emphasize or include, and how to best communicate the information on the map. Also the content. What do you consider essential that needs to be conveyed accurately? Maybe it's the settlements, maybe it's the rivers. So you just determine what you want to retain and what you want to exclude. One thing, you look at the map boundaries. So you consider how reducing or enlarging the map will affect the visibility of the map boundaries or any key references. Some of the map boundaries are things like municipal or town boundaries. You can have district boundaries. Like on this map here at the town, we have a boundary, the Kisumu town boundary, right? So you try to look, will it be affected or not? Another thing, you look at projection. Will reducing or enlarging your map using create inaccuracy or accuracy of the map, depending on how projection it is, or in representing of the map, so that you don't have exaggeration or skipping of items. So you need to consider that. Another thing, you look at the clarity and legibility. You ensure that the reduced or enlarged map remains clear and legible with easily recognizable features and labels that are easy to read. Another thing is the color and contrast. Consider how the reduction or enlargement of the map may affect the colors and contrast used. Ensure that the color remains visually appealing and that important information is highlighted effectively. So another thing, like on this map, you can see different colors. We have the blue probably for water, we have the black ones, the brown for contours, we have the black ones where we have motorable trucks. Yeah. So you're gonna consider that if we have green there, so you need to be careful. So we have a question there that you draw a square of 10 centimeters by 10 centimeters to represent the area enclosed by Eastings 00 and 10 degrees and Northings 80 and 90. So our Eastings are these ones. Eastings 00. So it's from here, yeah, to 10 here, because they're moving towards the east. They're dividing, so the grid. So you'll use that 00 to 10 here. Then for Northings, 80 is here. So you look at the Northings, 90 here. Okay, so this is the distance. So you're seeing we have the distance to be covered. So 00 here, we have 10. Then from here, 80 to 90 here. So this distance is what you want to fit into a sheet of paper, like you can see this one is plain. Want to transfer the data. So I will draw the 10 by 10 centimeter using a pencil and ruler. So I have my ruler, want to measure this. Okay, so we have the inch side and we have the centimeter. I want to use the centimeter side. Yeah, so here I am. And you're saying it's covering 10. Yeah, so it's 10. Then also this one is 10, 20. But if you get to count the number of grids, you'll find there are 10. Okay, so count the grid 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we can get to transfer that. So here I've already drawn the 10 centimeter horizontally. We want to measure for the vertical one. So 0 here, and I get to join. Okay. There you go. We have 10 by 10. So you must say 10 centimeters, 10 centimeters. So you already earn 1 mark. We were saying the river, for example, starting as the third one, 1, 2, 3. Yet here we're reducing by 2, so it will be 1.5. So here I'll come and measure 1.5. Some of the features that were supposed to be included are the photo principle for this one. We have the Chiga Market, River Bay here, and what else? And the all-bound surface, all-weather bound surface, that one, the road. So, for example, for their photo principle point is here. This is 12. So divide by 2, you'll find 6. So it will need to be accurate when you're transferring. So 12 divided by 2 it is 6. And remember here it is in the first box. So within the first box should actually have a half of it. So here where we have the 6, we get to denote. Okay. Then we have the all-bound weather. We can also get to fix it accurately. Okay. So you should have something of that sketch, or like this one. Yeah. See how beautiful it is. Though the river is not that visible. So that's how it should appear. Okay. Hope you've learned something. Until next time. Bye.